This is the first lesson to review literal equations. We're going to go back and actually start by going back to, I think it was module 3, where we looked at graphs and we looked at equations of lines. And you can see the different forms that we looked at this point for linear equations. Standard form, where a, b, and c are integers. Not just integers, a must be positive as well. And slope-intercept form, which starts with y equals, where m is your slope and b is your y-intercept. And the point slope form, which we use when we have a slope and a point, which when we have this form, we can actually switch between these things. So depending on the question that's asked, sometimes we want it in standard, sometimes we want it in slope, and sometimes we want it in point slope form, because each of those different forms have certain properties that can be useful. So what we're going to look at is reviewing how we switch from different forms to different forms. So we're going to look today at how you go from standard form to slope intercept and how you go from point slope to slope intercept. And essentially this will be a review. And then the following lesson, we'll look at some different equations that we also want to review. This is going to be particularly important for your sciences and also for things like geometry and also for algebra 2 as well. So just that reminder that I mentioned again, for standard form specifically, no fractions or decimals, and a must be positive as in the number of x. So we have a couple of steps here on how we're going to do this. So when we're trying to go from this form here, the one that's in standard form, to the one that's in slope intercept, then we're trying to get y by itself. So to do that, we have to do opposites. So we have to move the x term to the other side. So depending on which term it is, if it's a positive term, you do the opposite by doing a negative term. Or if it's a negative, you do the opposite and do the positive. In theory, if it's in standard form, it should never actually be negative. So really, we should just be always subtracting the 8x term here. Now, we have that little sketch pad here, so we can try and write these. So apologies, this won't be the neatest, but this will be more so we can see what we're trying to do here. So I'm going to follow step 1 from the side there. So I'm trying to move this 3x to the side. So I do it by doing the opposite. And remember, we have to do it on both sides. So I got to subtract 3x from both sides. And the reason we do the opposite, of course, is 3x take away 3x is 0. So what I get left with is positive 7y, which I can just put as 7y. 14 take away 3x. Don't put 11x here. These are not like terms, so we can't combine them. You can either put 14 minus 3x, or more commonly, we would normally put negative 3x. And then as we got the 14 here, we would put positive 14 here. So that's the completion of step 1. Step 2 says divide by the coefficient of y. That's the number of y's. So in this case, 7. So I don't really want 7y. I just want y by itself. So we divide each of the terms by 7. As long as we do it on both sides, it doesn't change the equation at all. 7 divided by 7 is 1, so we just get left with y. And then we can just go ahead and simplify this. So negative 3x over 7 doesn't actually simplify. And 14 over 7 gives us 2. Now, if we want to check to see if that's correct, what we can actually do is we can actually type in that answer. So I think it's negative 3 over 7x plus 2. And then just take a look at the picture, and you can see that is indeed the same line. So we know we have the correct answer. Just to do one more, x minus 2y equals 6. So I'm going to move I'm trying to get y equals again. So I'm going to move my terms that aren't y to the other side first. So the opposite for x would be negative x. That would cancel. Very important, we don't forget the negative here. So this is negative 2y. And once again, I'm going to put my x term first. So negative x. Remember, this is negative 1x if we need to think of it that way. And 6 is just positive 6. And then we're going to divide by that coefficient, which is this time negative 2. If we're not very good with the number side of this, don't forget, you can actually use the Desmos calculator to check all these calculations as well. So I'm actually going to put that 1 in here because I think that's going to be helpful. So you see this as 1/2. The two negatives are just going to cancel out and give me a positive. So this would be 1/2 x. 6 divided by negative 2 is negative 3. And like I said, really use a Desmos calculator if you're not sure. And just so we can check if that is correct, let me go ahead and type in the answer. And you can see that is indeed the same answer. So that's how you're going to check. That's how you're going to switch from one form into the other form. And then from here, there's a couple for you to try. So you should certainly try problem 3. You can do that same check once you have the answer, type it in here, just make sure it covers the same line. And also for question 4, you can do the same. Now, after you've tried that, one thing that's also another way for doing these questions as well, if you don't like that method, is you can look at this as purely in a graphical context as well. So slope-intercept means we need to know the slope and we need to know the intercept. Now, you can see the intercept very clearly from the picture here. It's +2. And then to find the slope, we're just looking for those corners of squares where the line actually goes through. So I can't do this here because it passes through the vertical line, but not the horizontal line. And yeah, same here. Unfortunately, I didn't trim this picture very well. It does go through this point here. So I go down 3 squares across 7 squares. So that would be -3/7x and then +2. And I could have done the same with the other ones as well. So the other example that I did earlier, you can see this one goes up 1 and across 2. If necessary, you can go up 3 and across 6. 3/6 is just 1/2 as well. So 1/2 x minus 3. And you'll see those were the 2 answers that I gave. And the 2 that you had to try, you can see that goes up 4 and across 3. So this will be 4/3 x minus 4, because that's where it goes through on the y-intercept. And for number 4, it goes down 1, 2, 3, 4, 5, 6, and across 1. -6 divided by 1 is -6. So this would be y equals -6x. And then the y-intercept is 2, so +2. And that's the end for the first section, going from standard form into slope-intercept form. Now, point-slope formula, that's this one here. All these values have specific meanings. So y1 is your y-coordinate, not y, which a lot of people assume incorrectly. And once again is your slope, and x1 is your x-coordinate. Now, just to recap how we actually used this before. So if we had a question where we knew the slope and we knew a point, then we would use this formula. And I've color-coded all these little numbers here so you can see exactly where they fit into the formula. I do have to be careful with negatives though. So if I'm subtracting a -2, just remember that the 2 negatives would combine to make it positive here. And for this part here, all I'm doing is I'm just distributing. So 3 times x and 3 times 4. And then to get it to say that y equals, I would just be doing opposites again like I did previously. I'm trying to bring things away from my y. So instead of adding 2, I would be subtracting 2 from both sides. And -12 take away 2 is -14. Same thing, and this time though with a negative fraction as the slope, and actually I switched the points over. I made the x value negative this time. Same thing, you can substitute them in. Once again, 2 negatives make a positive. I can go ahead and distribute 1/2 times x, 1/2 times 2, and then that same thing at the end. Bring terms away from the y, so instead of subtracting 6, add 6, and clearly 1 add 6 would give you 7. So for these questions here, we've actually already put them in slope-intercept form. So all we're going to do is we're just going to do those last couple of steps. So as the question's already written here, I'm not going to rewrite this question out here. I'm just going to do that next step. So step 1 says distribute. So -x is just -x. And remember, this is -1 if that helps. So -1x is just -x. And -1 times -8, or 2 negatives make a positive with an 8. That gives you +8. And then to move that 9 away, do the opposite. So instead of adding 9, you would subtract 9 from both sides. And that cancels to give you y equals -x. And 8 take away 9 is -1. So not a big surprise here that we end up with the same slope here, because they're telling us this is the slope of the question. What we're really trying to find out is just what is that y-intercept. And if you type it in, you can check your answer by typing in what you think the answer is, and then just checking that it does indeed give you the same picture. Same for this one. Fractions, not quite so easy to distribute with. So if we're not so sure, we can always use our Desmos calculator. So 2/3 times x, that's just 2/3. 2/3 times 6, if we're not sure, we can just type it in. So 2/3 times by 6, and you can see that the answer is 4. So let me go back, and as it's 4, that would mean +4. And then bring that term to the other side by adding or subtracting, but doing the opposite. So instead of subtracting 4, I'm going to add 4 to both sides. And then as I go ahead and check, 4 plus 4 will give me 8. And I can do the same thing on here. I can just check just to make sure that is the correct answer by typing in what I think it is. And once again, you can clearly see that that's the correct answer. So there are a couple for you to try as well. So there's example 3. Once again, once you have the answer, I would type it in here just to make sure that it's correct. And then also answer 4. 6/7 not particularly nice to distribute with, so I would definitely check 6/7 times 21 on the Desmos calculator. Now, for those first 2 questions that I showed you, you can also do this question in a very different way as well. You can do this in a very graphical method as well. We already know the slope because that's the m that goes at the start here. So that negative x, I already knew that was the slope. All I'm really trying to do is find out what this y-intercept is. Notice from the first equation, as I graph it, you can just look at the picture and actually see that it's -1. So we could have also used that as a good way of checking our answer. You still want to practice that method of algebra, though, for more difficult questions and also for future questions as well. But this is just a clever way of making sure we got our correct answer as well. So 2/3 x, I already knew this was a slope of 2/3. And then look from the picture, you can see that it goes through 5. So I know the y-intercept is 5. And you'll be able to check your 2 answers for the other 2 slides that same way. That concludes this first lesson on literal equations. Go find the assignment in Canvas and go and practice a few of those questions there.